So this is all about, first we will see data sets and the types of data sets, correct? So we have the type as record, we have graphs and networks, we have ordered data sets and the special image and multimedia data set. So what do you mean by the data set of type record? So here we have the data in the tabular format. It is a relational records or it is a data matrix, uh, text documents and term frequency vectors, and we have the transaction data. So the example which is given here, the document 1, document 2, document 3, and we are checking the term frequency, like if the term team, how many times that team term has appeared in a document 1, how many times the coach term has appeared in document 1, 2 and 3. So that frequency, so this is how I keep a record of a data. So this is one of the type of data set. This is how I keep the records in the record of the given data. We can have graphs and networks. For example, we have this World Wide Web, then that is as a network. Then we have the social media or the information networks. Even when I go to the branch of chemistry and when I say that there is a molecular structure, that is in a sort of a networks, right? Even I have a mind maps which is in a sort of a networks. I have a graphs which also says about my data. So that is my one of the data type of a data set. The next type of a data set is my ordered data sets, right? So I have this video data. That video data is what? It is a sequence of images. The ordered sequence of images is my video data. We have this temporal data, which is a time series data. Then there is a sequential data, which is my transaction sequences, and genetic sequence data. So this is how I have the ordered data sets, where my order is also important. My order says about the data. So I say it is my ordered data set. And then lastly, the type of data set which we should look for is my spatial or the image or the multimedia data set. So which includes my maps, it includes my images, it includes my video data set. So these are different types of data set which are available with us for the research purpose. Correct. And now we will see about the data objects. Now data sets are made up of data objects. A data object represents an entity. In a sales database, the object may be customers or my store items and sales. Even if we consider the medical database, the objects can be patients. In the university database, the objects can be students, professors, courses. So like this, for every data sets, database, the object is very much important. Data objects are typically described by attributes, or we can say features. Data objects can also be referred to as samples or examples or instances or data points or objects. So we will be referring in our complete this course the data objects as samples or sometimes as examples or instances or data points or objects. If the data objects are stored in the database, they are also called as data tuples. You must have heard this in database, that like data tables, correct? So that is the rows of database corresponding to the data objects. The column corresponds to the attributes. So we will see different attributes now, various types of attributes. What is the attribute? Attribute is a data field representing the characteristic or the feature of the data object. Now in simple terms I will tell you, student का database है, right? Student के database में student को कैसे आप एक्सप्लेन कर सकते हो, या स्टूडेंट के क्या फीचर्स हो सकते हैं, या स्टूडेंट के क्या कैरेक्टरिस्टिक्स हो सकते हैं. द कैरेक्टरिस्टिक्स ऑफ द स्टूडेंट कैन बी रोल नंबर, नेम, मोबाइल नंबर, CGPA of semester 4th, CGPA of semester 5th, even the results of 12th standard, results of 10th standard, correct? So these are all represented in columns, right? सारे columns ऐसे होंगे, and rows में क्या रहेगा? Student 1, student 2, student 3, student 4, student 5 information, right? So whatever I represent in the columns is my characteristics or the features or the object, and they are called as attributes of data objects. The nouns, attribute, dimension, features, variables are used interchangeably in the literature. So these columns of your given data can also be called as dimensions, can also be called as features, or can be called as variables. The term dimension is commonly used in data warehousing. A machine learning generally use the term as feature, while the statistics may, right, statisticians prefer the term as variable, but all of them means the same. They means the attribute of my data object. Understood, all of you? So again, I will repeat. If you go to data warehousing projects, this attribute may called as a dimension. If you go to the machine learning field, these attributes are called as a features. And if you meet one statistician, the statistician may call this attribute as a variable. So data mining and database professionals commonly use the term attribute as well also, correct? So these attribute describes the customer object, can include customer ID, name, address. The observed values for the given attributes are also called as observations. So when I say I go to a field research, I say that I mark the observations. What does it mean? I mark the values of attributes from the research field. Right? A set of attributes used to describe a given object is also called as a attribute vector or a feature vector. तो एक ऑब्जेक्ट है, ऑब्जेक्ट क्या रिप्रेजेंट करेगा? एक रो का डेटा पूरा. तो वो रो का पूरा जो डेटा होता है वो आपका फीचर वेक्टर होता है या अट्रीब्यूट वेक्टर होता है. Understood, all of you? So the distribution of data involving one attribute or the variable is also called as univariate. A bivariate distribution involves two attributes and so on. Right? So we have some defined types of attributes. They are nominal, binary, and ordinal or numeric. Right? So three types are nominal, binary, and numeric. And then this numeric also can be given as interval scaled and ratio scaled. Right? So let's see one by one these attribute types. So in a nominal attributes, nominal का meaning क्या होता है? Relating to the names. So the values of nominal attributes are symbols or the names of the things. So each value represents some kind of a category, code, or a state. And so it is a nominal attribute. The values do not have any meaningful order. So even when we say the enumerations, these enumerations which we represent, have you seen the enum class anytime in C, C++ or Java? We have these enum classes over there, right? Or enum is a type of enum is a data type which we generally use. So that enum is my nominal attributes. For example, the nominal attributes is like hair color and my marital status. So what does this do? These two attribute describes the person object, right? So in some applications, possible value for the hair color are black, brown, we have red, gray, white. Correct? So we don't require any order for this. These are just names, and these names represent my object, a characteristic of my object, right? The attribute marital status, right? It can be single, married, divorced, widow, like this. So these are the two nominal attributes. The another example for the nominal attribute can be occupation. It can be the teacher, dentist, programmer, farmer, and so on, right? So though we say that the values of nominal attributes are symbols or the names or the things, it is possible to represent such symbols or names with the numbers also. So for example, we can say that we can assign a color codes to hair color, like a 0 for black, 1 for brown, and something like this. Even the customer ID, so the possible values are all numeric. However, in such cases, the numbers are not intended to be quantitative, right? So we cannot perform the mathematical operations on these nominal attributes. Can we add black plus brown hair color? Okay, do the addition of hair, average of the all hair color. No, not possible. So we cannot perform the mathematical operations on these nominal attributes. Please make it clear. Again, I will tell you one more example. Suppose I want to make an average of age of a student, average age of my class. So what I will do? I will be doing the average of the age column. Correct? तो मुझे average मिल जाता है. Can I say that average hair color of my class? It is not possible. So that is what I say, that mathematical operations are not possible with nominal attributes. Right? So we cannot add, even we cannot do the adding or subtracting of this. Correct? Because the nominal values do not have any meaningful order, and thus they are not quantitative also. Right? The next attribute which we'll see is a binary attribute. Right? So a binary attribute is a type of a nominal attribute which take only two categories or two states, that is my 0 and 1. So 0 means absent, 1 it generally means as a present. So binary attributes are also referred to as a Boolean, as we all know, if two states corresponding to true and false. Correct? Means the example for this is like a medical test. The value of medical test is a binary. Either we can have a positive outcome or a negative outcome. Very much famous now, the COVID test, positive or negative. That's a simple result, right? So it's my binary attribute. Please remember, it is my binary attribute. The characteristics for this binary attribute is a symmetric if both of its states are equally valuable and carry the same weight. So there is no preferences on which the outcome should be coded as 0 or 1. The example for this can be a gender. So it says that male and female, these two values for the gender and which carries the equal weights. Correct? So that is my symmetric binary attribute. We have the asymmetric binary attributes also. So if the outcome of the states are not equally important. Now example can be positive and a negative outcomes of the medical test of HIV. So by convention, we code the most important outcome, which is usually the rarest one, by 1. That is my HIV positive. And the other one is 0, that is my HIV negative. So this is my asymmetric outcome or asymmetric binary attribute. And let's move to the next example, next attribute type, that is my ordinal attribute type. So an ordinal attribute is an attribute with a possible values that have a meaningful order. Right? The word itself says that ordinal. What does it mean? It has a meaningful order or the ranking amongst them. But the magnitude between the successive values is not known to us. Example of this ordinal attributes is like, suppose the drink size corresponding to the size of drinks available at the fast food restaurants. So this nominal attribute can have the three possible values: small, medium and large. Correct? So whether do you want a small cup of a Coke, medium cup of a Coke or the large cup of a Coke. Correct? So the values that have a meaningful sequence which corresponding to the increasing Coke size or Coke size, right? So however, we cannot tell from the values how much bigger they are. Say the medium than medium is than a larger one, like this. So one example of the attributes can be grades also. Say I have a grades as first class, a second class, first class, or the first class with a distinction. Correct? So these grades are also important. Like this, even I have the grades in my professional life also. Say there are lecturers, assistant professors, professors, assistant professor, associate professors, and professors. Right? So there is a sequence is important. The order is important for these attributes. Correct? Even these ordinal attributes are useful for registering the subjective assessment of qualities that cannot be measured objectively. And thus the ordinal attributes are often used in the surveys for the ratings. right? So customer satisfaction can have the ordinal categories as 0, very dissatisfied, 1 is somewhat satisfied, 2 is neutral, 3 is satisfied, and 4 is very much satisfied. Correct? These are a few examples of ordinal attribute. Correct? Now this ordinal attributes, we can perform the mathematical operations on it. We can have mode and median of it, but we cannot have the mean for the ordinal attribute, and we'll see this all in details when we go for the central tendency or the data central tendency later on. Please note that this nominal, binary and ordinal attributes are quantitative, that is, they describe the feature of object without giving an actual size of quantity. So these are attributes, are qualitative attributes. Please remember why I say it is qualitative attribute, because they describe a feature of object without giving an actual size or the quantity. The values of such a qualitative attributes are typically words representing the categories. About my attribute types.